Okay, so let's start. My name is David Maier, Principal Solutions Engineer at Couchbase, and this is Simon, my lovely assistant. No, Simon will do the demo today, right? So, okay, so let's start. So let's talk a little bit about history of our, history of our spatial views functionality. So who of you knows it already? Okay, yeah. So you already tried it out, played around with it as part of version 3.x, I guess, right? Okay, yeah. So it was already there, marked as experimental, and since then we did some performance stability improvements, and it will be GA in 4.0. So when 4.0 is released, then it will be generally available. Okay, and even then some further improvements will follow, something like radius queries, something like directly indexing on polygons and stuff like that. So currently polygons are indexed as regions, here as boxes more or less, and you can then post-process them, and the same for radius queries. You can perform bounding box queries already, and then you can just find something which is within the radius within your box. But this will be added later. Okay, so a short introduction is that our spatial views functionality is basically working exactly the same as our views functionality from a higher point of view, right? So the API is really feeling
It's one of those
similar, right? So you can log into our admin UI, you can create a spatial view there, you can use a REST interface which is looking nearly the same. I will explain some differences, and spatial means in this case not just that it's geodata, it's actually multi-dimensional indexing, right? So let's explain this later a little bit more detailed. Okay, who of you knows how views are working in Couchbase? So in general, so okay, fine. Okay. Typical use cases, right? One use case is actually not related to any geographic information, right? So it's just related to multi-dimensional data analysis, which means if you see this cube here, then this cube has 3 dimensions. One is the age, one is the income, and one is the education level. And what our spatial views are allowing you is that you can use them to index based on those multi-dimensional data set, right? So one downside is that, for instance, the education level is not a numeric value. So I should have said that you can index based on dimensions. Those are expressed as numeric values, right? Education level is something like Master of Science, Bachelor of Science, and in most of the cases, you can just map those discrete values to numeric values. So for instance, a Bachelor of Science is mapped to the value 4, and the Master of Science is mapped to the value 5. Other examples for this multi-dimensional analysis is timestamp data, right? So for instance, log analysis. So you have a timestamp and, for instance, a log level. Okay. I think it will be explained later by example. Okay, so the traditional use case is geodata. Geodata means that you re-index on geographic data. This geographic data is expressed as GeoJSON, and a GeoJSON document is looking like this. Yeah, could be a polygon, could be a point, could be a line string, so a line or multiple lines in sequence. Yeah, so all those data can be indexed, right? And later you can perform bounding box queries based on this. Or you can do it combined, right? So something like all persons with an age greater than 10 in San Francisco would mean that your 2 dimensions in the first step are the points of your map. In this case, there's a map of San Francisco. And then you can imagine to have it a little bit layered. It's hard to show or to visualize this, but in this case, the next dimension would be the age, expressed as numeric dimension there. Okay, so a little technical overview. Our spatial indexes are based on R trees, right? So who of you knows what an R tree is? Okay, so let's explain it. Most of storage engines are using B trees for general indexing, for secondary indexes and stuff like that. And geodata is usually indexed by using R trees, right? Which means we are talking about regions here. In this case, we have one region, which is called C. And this one region, C, contains subregions A and B, right? And those regions are then containing the points 1, 2, or B contains 3, 4. The tree would look like this, right? Not exactly like this, but logically like this. Or it would have C contains A, contains B, A contains point 1, A contains point 2, for instance. And what you find here is a definition of the regions in the nodes of your index. In this case, we are storing the edges. So x min, this point, to x max, this point, is the first edge of our region. And the next one is epsilon min, epsilon max is the next region. It's the other edge of our region, right? And A is expressed exactly like this and this, right? Okay. The cool thing here is that this kit could not just be 2-dimensional. So if you index on geodata, you're talking about 2 dimensions, right? Latitude, longitude, right? Or if you talk about spatial indexes in Couchbase, then this could be multidimensionally, right? So x, y, z. And then you would just have multiple entries here in your index node, right? So you could easily say something in my hypercube, as explained here. In my hypercube, I would like to have a specific or hyperregion, right? Okay. Okay, so let's jump from this internals, let's say, or to how to use it, right? So, and there are basically 4 ways to emit data into such an index. And the first way is just to build a flat array, right? Wait a moment. Yeah, no, the first way is actually to emit a GeoJSON object, but my presenter is currently not working as expected. So what you do is you define a GeoJSON object based on some document attributes, right? In this case, it's a point. The point has a longitude and a latitude, and finally, you emit this GeoJSON object, and optional a value. So you can index on GeoJSON directly, and if you query it, this is important, what you will get is you will get the original document ID of the document which you processed, right? So function on doc. You will get the emitted key. In this case, the key is based on the longitude, latitude in this GeoJSON one. You will get the value, which is this name, and you will get the geometry information, right? Which is special. If you don't index on this JSON documents, you don't get this geometric information. Okay, next way is to use a flat array. So in this case, this flat array is just a sequence of values. And as explained before, we had this x min, x max. And if you provide a flat array, x min and x max are just falling together to one point, which is x, right? So one point x, epsilon, z. This is your flat array. So you can, in this case, just say, okay, I have geojson.coordinates. This is, in this case, just, again, the longitude, latitude information. And instead indexing on the GeoJSON directly, because we don't have any geometry information here, you're just saying, okay, I'm emitting this array with the name. Then you have a multi-dimensional use case, as Bruce Leigh described, right? And the next way is to use it as a min-max array. In case of a min-max array, or important here is that if you query it, you don't get the information about the original structure, so you don't know if it was a point, a polygon, or something like that, right? Okay, so the min-max array is actually a more generic way to do it compared to the flat array. The min-max array gives you the chance to say, okay, I really want to store those regions as they are defined in this R tree, as explained before, right? So you can say something like emit min-max, 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 right? And then a value. By actually indexing on a hyperregion which you define by yourself. Okay, and the last way is to combine this, right? So, which means you can easily combine, as mentioned before, those geodata, this geographic data, with as much dimensions as you would like to have, right? And our view definition can look like this. So you can have an array which has at the first position the geo information, and all the other positions could be the other dimensions, right? So, and it will automatically find out that that there was a GeoJSON object part of the array. So what you get then is, again, this geometry information in your query result. I will answer questions after it, okay? Okay, so as mentioned before, here just a little example how such an output is looking like. In this case, we indexed on a polygon, and the polygon had some coordinates. And as mentioned before, you can still get the information about the original structure, right? If you query the index. Yeah. Simon will show you something regarding this, but basically you can vary our spatial views via our REST interface, and it's more or less feeling the same as our normal views, or you can use start range, end range in order to specify which box you would like to query. And as mentioned before, this box could be even something which is multidimensional. And an example output could look like this, right? So you have total rows, then you have the original ID of your document, then you have the key. In this case, the key is a min-max, whereby the min-max is falling into the same point. As mentioned before, then you have your value, which is here Puri, which was emitted by me. And then you have the original indexed geometry, which is type point, and then the coordinates, right? And you can see here is the flat array version, whereby the key is actually this min-max per dimension, right? Okay, so Simon.
Thank you, David. Okay, just let me get this lined up. So I'm going to demonstrate essentially what David has just said, which is the option to do a geoquery using both a bounding box, which in this example is just the bottom left and top corners of the view that we have of Google Maps window there. And then I'm also going to show how we can do it with multidimensional queries, so combining both the geospatial data and also some date ranges. So we can say we want things in this area, but only happening between these two dates. So this is using Couchbase 4, the developer preview, Node.js for the back end, Express for routing the REST queries, and AngularJS for the front-end stuff. And I would say I am not a web developer. I'm just a real Couchbase enthusiast. And it was quite easy for me to do it. So I recommend that you just dive in and try. So at the moment, we are looking at a region around the London office of Couchbase, which is somewhere in the middle of this map. We can jump back and forth to Levi's Stadium and London. The only thing that I'm using Google Maps for here is really to visualize the roads and the stadium and to get the coordinates of the bounds here. So on the right-hand side, we're just getting a readout from the Google Maps API using Angular of the latitude and longitude data, the zoom factor, which is really just for fun. It's not helping us with the query. But you can see as I zoom in and out that the bounds change. So these are the points that we're using to feed into Couchbase for the query. So I have this set up so that as I drag and when I release, we fire off a query to Couchbase, and we pull back any events that are happening within that area. So here we go. And they all come back. So what's happened when I've done that is we've just said, OK, a bounding box is the northeast coordinates and the southwest bounds. Find me any items in the database which were indexed and fall within that region. So this is not including the dates. So you can see the dates up at the top right-hand corner, but the dragging function is really just pulling through absolutely everything. And this is hipster central, so the database is a load of kind of music events, museum stuff, coffee bars. There's loads of them. So lots of couches. If we click on them, we've actually emitted from the database in the query. So the description of the event, the location, and the times that it's happening. One key thing to look at here is I haven't called the time-based query. So when is actually here an array of the various times that an event might be occurring. If I decide, for instance, which I'll demonstrate with Levi's Stadium, because when we have so much data, it's kind of hard to find the right point again for me. But we can filter out to the exact time range, and we'll only get that result back. So I'll just show you quickly as we have a bit of time, I think. David talked about the function that we're using to generate these indexes. So here, we are constructing the GeoJSON object, which is a point, just as David showed in his slides. And the coordinates are being constructed by looking at the document in the database and taking the longitude and latitude and constructing a point GeoJSON object from that. So we're also looking on this one at, it's best practice with the Couchbase view to only emit the fields that you want. So in this one, the actual document I could show you is really quite large and has lots of identifying tags and sort of subcategories. We don't want to emit the whole document. We're increasing the size of our index doing that. So we just here choose a kind of sub fields within the document that we want to use for our application. So with the, and in this one, the emit statement, we're just emitting the GeoJSON. So this is the one used without the dates. The difference between the one with the dates, we emit the GeoJSON, and we emit a long representation, so just the kind of Unix epoch since 1970 of the dates that are fed in from the web side of things. And in this respect, we have a multi-dimensional index, both the bounds of the geo and also the dates. OK, so let's head over here. And if we just take a look at, let's say, what's happening on the 1st of June to the 3rd of June, the get events button here is going to fire off my actual query, including the date range. So Levi Stadium, one result. Couchbase Connect 2015 is happening here. And on this one, we've emitted, so actually, this is my fault on the front end. We're only getting the most recent version popping up, so 06, 03, which is the later date. I can prove to you that this is doing what I say it's doing. Fingers crossed, demo gods, by putting it up to the second and doing the same thing. there we're only getting dates up to the 2nd of June. So I'll just quickly jump over and actually show you here. What we're feeding into the query at the bottom end here is a start range, which is the bounding coordinates, including the date, and an end range with the end date that I've selected through the web there. So if I expand the range now to the 4th and go get events, we're getting another event. I thought I was going to be clever and include the kind of location of this room within the stadium, but it turns out it wasn't in the right place, so I've set it at the other end of the hall. But this is the spatial views presentation. So that one comes up only when I include the 4th as my date filter. So that's pretty much it. A quick demo just shows you the capabilities that we have. You know, these are standard JSON documents in Couchbase. We're just building our spatial indices, and you can see that the query is quite responsive. I'm using the stale feature, so I'm saying I only want things. I want the index to be up to date with the latest changes when I make my request, and I'm limiting it to 500 responses because otherwise I end up with loads of stuff coming back to the browser, and it can really slow things down. That's it for the demo. Please fire away. David and I will be very happy to answer any questions on it.
Yeah.
Is this on GitHub yet? Or?
I will put it on GitHub, so it'll be on the Couchbase Labs. But I'll tweet it out. My Twitter is Simon Leigh 0x01, but I'll tweet it. It'll be on the Couchbase feed.
007, no. Any other questions? Yeah.
So can we have queries with the geo-radius information to find a specific location within this radius?
You mean radius queries? Radius queries are not yet supported, but how radius queries are usually working, which means what your GIS system is usually doing, right? It's performing a bounding box query in the first step, and then it's filtering based on the radius, right? So what you can do is you can do exactly the same. You can do a bounding box query, and then based on this radius, just make sure that you only get something which is in your circle, which you need, right? But it's not yet supported in our views. Any other questions? Yeah?
Do you support the area boundaries? Like polygon is like an area boundary.
Yeah, we support polygons, but not fully, let's say this way. So what happens is if we index on a polygon, we will just find the region around this polygon, right? And we'll index only on this region. So it's more or less approximated. So what you can do is you can find this polygon, but you have then to double check by using the geometry information if it was really this polygon, right? Yeah.
I noticed that the keys are based on the coordinates.
Yeah.
So you don't run into issues of two places quite close to each other? Or,
Sorry?
you don't run into 2 points of interest which are quite close to each other if it's based on coordinates?
Yeah, I don't think so. If something is close to each other, then it has 2 different coordinates. Those are just quite similar. But in the tree, they will be in the same region then, let's say this way, those points. Whereby regions can also overlap in the tree, right? So, not sure if this answers your question.
So I mean, I can follow up a little bit on that. So
Okay.
I'm not sure if it's quite what you're asking, but for the latitude and longitude and date, the original documents, one document with one latitude and longitude has multiple dates that it's occurring on. So it's maybe an event that recurs. And in that situation, I'm iterating over, in my view, I'm iterating over the array of dates. So things are, multiple emits are made, multiple documents are emitted, which have the same latitude and longitude, but have another distinguishing characteristic, which is the date in this case. And you then can select each of those. So they can be returned back to your application, and you can look at those and decide what you want to do from there.
It's basically flattening down the date dimension, because the data dimension is in an array, and you emit it as flat values, then separated values. Yeah. Any other question? Yeah.
Is it possible to register an event so that when something comes into your index within a predefined geographic region?
Yeah. Yeah. This is, it depends, let's say it this way. Not by, so you could actually poll our geo indexes, so you could something do like polling the index from time to time in order to find out if something changed, right? Or if you don't want to use the geo index, but just the geo data, so just the information if something which has a geo property changed, right? Then you could even use DCP or our Kafka connector in this case, right? Okay. Any other questions? No, so we are done. Thank you.
Thanks very much.